Good day, everybody. My name is Maja Slingerland and I work for Wageningen University. I will share with you impacts and opportunities of sustainable oil palm cultivation in Asia. I will make some comparison with coconut, rubber and tea where appropriate. Oil palm is a highly productive crop. It has a potential oil production of 8 to 12 tons per hectare. Averages of 3.8 tons per hectare are currently found in Indonesia and Malaysia. National averages include high numbers of suboptimally managed fields by smallholders and immature and overaged trees, which are part of a replanting task. Average palm oil production per hectare is about 4 to 5 times more than the average coconut oil production of 0.8 ton per hectare. In Indonesia and Malaysia, large commercial oil palm plantations have higher yields, followed by contract smallholders that benefit from company and government support. Independent smallholders with lower access to knowledge, inputs and markets have lower yields. Policy support and organization of the sector is crucial to favor high and sustainable production and processing, and effective trade for companies and smallholders. Malaysian Palm Oil Board and Indonesian Oil Palm Research Institute are dedicated to oil palm research. Partnerships between companies and smallholders and policies are needed to favor high and sustainable production by smallholders. Let's look at biodiversity now. When you convert a forest into plantation crops, you will certainly have a decrease in complexity of the ecosystem. That is often not desired. Therefore, Malaysia and Indonesia have started to protect high conservation value areas, high carbon stock areas. They've established corridors and they follow a moratorium on deforestation through national policies and national and international certification schemes such as MSPO, ISPO and RSPO. To compare the plantation crops, you need a fair comparison. And that means you need to compare the same place in the landscape, the same prior land use, the same establishment practices, and the same methods and indicators of biodiversity assessment. Therefore, international studies comparing plantation crops are often non-conclusive. Species assemblage present in plantation crops seem to be fairly similar amongst them. But is it possible to increase and facilitate biodiversity in oil palm? Yes, it is. In Malaysia, biodiversity in oil palm is increased by alley cropping and grazing. In Indonesia, richness and composition of soil macrofauna in oil palm is higher with no herbicide use. In Indonesia, they also point out that in oil palm there's an extra above ground soil biodiversity in axils of the trunk, supporting the ferns. In Asia, Indonesia and Malaysia, they propose to reduce the use of pesticides by using integrated pest management, such as barn owls to fight rats. And they also favor no blanket spraying of herbicides, but site-specific weed control by mechanical weeding or grazing. And what now about nutrient use and nutrient use efficiency? Oil palm uses on average higher amounts of fertilizer per hectare than rubber, and comparable amounts as coconut and tea, depending on targeted production, of course. Due to its higher oil yields per hectare, oil palm uses much less fertilizer per ton of oil than coconut, and has thus a higher nutrient use efficiency. In all plantation crops, fertilizer use can be reduced by recycling nutrients present in crop residues such as prunings, empty fruit bunches, and wastewater, after treatment, of course. And what about soil loss and soil degradation? Soil acidification due to nitrification of nitrogen from ammonia-based fertilizers such as urea occurs in all plantation crops. Nitrate-based N fertilizers are better than urea. Acidity problem is well known in tea where it is treated with magnesium fertilizer. Oil palm grows well in acid soils and is not necessarily causing soil acidity. But application of empty fruit bunches, fronds and boiler or bunch ash decreases acidity. Soil loss is generally favored by bare soil and steep slopes. It needs to be avoided. Input use in oil palm plantations does not lead to environmental pollution. Fertilizer application should follow the 4 R's. Right composition, right rate, right place, right time. This prevents nutrient loss to the environment and is cheapest. In Indonesia and Malaysia, nutrient applications in oil palm are based on soil and leaf nutrient analysis to spot deficiencies and tailored to replace the amount of nutrients that are removed within harvest. In Indonesia and Malaysia, the good agricultural practices promote keeping pruned fronds in the plantation to recycle nutrients and bringing back empty fruit bunches, which covers about 27% of the nutrient needs, both to reduce inorganic fertilizer needs. Also, wastewater irrigation can bring nutrients back. In oil palm, pest and disease incidence is very low, and it's often taken care of by integrated pest management. Therefore, pollution of agrochemicals to the environment is low. Water is a scarce resource, and therefore it needs to be taken care of with caution. Let's look now at the water use and water footprint. The water use in liters per hectare per day is quite high in oil palm, 35,000 liters, but similar to rubber with 33,000 liters. For coconut, it's much less. However, when we look at the water use per ton of oil, we see that for palm oil it is less than for coconut oil. And for both it is less than per ton of usable product of rubber and tea trees. We can conclude that the water use efficiency of palm oil is much higher than the water use efficiency of coconut oil and of the water use efficiency of the other crops. But is the high water use now depleting soil water? Let's see. Oil palm is normally cultivated in areas with 2,000 to 2,500 millimeters of rainfall. This rainfall is then going into the ground and serves the roots to let the palm grow. With evapotranspiration, not more than 1,000 to 1,600 millimeters of water disappears per year, which means there's still water left to recharge the groundwater. So, despite its high water use, oil palm is not groundwater depleting. Of course, we need to take care that surface runoff is not taking place, because then water will leave the system and some deficits might occur. So what are now practices to facilitate groundwater infiltration and to reduce soil loss and degradation? In Indonesia and Malaysia, they recommend to sow and fixing cover crops at crop establishment, such as pueraria or mucuna. They also recommend mulching with crop residues, such as empty fruit bunches and pruned fronds, and use of compost and manure. Infiltration was found to be highest under front stacks. Furthermore, weeding should be done only on the circle and the path to facilitate harvesting, and the rest of the area should remain untouched. It's recommended not to plant at steep slopes higher than 20 degrees. In India, they say when planting on slopes, use contour planting. And in India as well, they promote water harvesting ponds for irrigation water. In Indonesia and Malaysia, these good agricultural practices are captured in policies and in ISPO, MSPO and RSPO certification. What now about carbon and greenhouse gas emissions related to oil palm cultivation? Oil palm has high photosynthetic capacity, using light more efficiently than tea and rubber, potentially producing more biomass when well managed. Cultivating oil palm on land that was degraded or priorly used by annual crops will increase carbon stock per hectare, more so when palms age. In Indonesia and Malaysia, you find good agricultural practices in oil palm certification and policies, some of which are no burning of biomass at establishment and no cultivation on deep peat, both to reduce greenhouse gas emissions. They also promote soil cover with organic materials, as was mentioned in the previous slide. For coconut, rubber and tea, prunings are often removed as firewood, and for coconut and rubber, stems are removed for timber. Husks of coconut have alternative uses and are not returned to the plantation. For these plantations, the residues will not contribute then to carbon stock in the plantation. It's often said that oil palm generates a lot of waste, as only 10% is captured in the oil. This is not true. You can see that the front and the trunk and the empty fruit bunches will be used as mulch, restoring nutrients and carbon to the plantation. Palm kernel cake can be used as animal feed. Palm kernel shells and mesocarp fiber are used to fuel the boiler of the factory, and their ashes can be used to fight acidification of the plantation. Pomé, palm oil mill effluent, can be used to generate biogas, can be used as fertilizer and irrigation water, but it can also be used for added value, for instance, to make bioplastics. But one of the wastes really needs some consideration, and that is wastewater. Wastewater from palm oil, coconut oil and rubber production are all unsuitable for discharge to the environment. When you look at the table, you see in yellow that for oil palm pomé and for mechanized virgin coconut wastewater, the COD, BOD and TSS are very high, which means they are very unsuitable for discharge. Other crops or other processing methods lead to wastewater with other characteristics. And then the COD, BOD and TSS may be lower, but for instance for rubber, chemicals are found in wastewater which are also not advised for the environment. Wastewater quality depends in general on scale and type of processing. On small scale, the costs for processing are often too high, and therefore discharge to the environment of untreated wastewater is a real danger. In Malaysia, legislation on wastewater discharge stipulates that the wastewater need to have a BOD lower than 20 milligrams per liter. In Indonesia and Malaysia, technologies for wastewater treatment, use and reuse have been developed. But finally, palm oil and coconut oil are produced for human nutrition, and therefore we need to look at the human nutrition and food safety aspects. What you see in yellow are positive aspects for palm oil. Palm oil has lower amount of saturated fatty acids, which means it is better for cardiovascular diseases, and palm oil have carotenoids and antioxidants, which are known as health promoters, while they are not found in coconut oil. There are also 3 substances that need further consideration, such as mycotoxins that you find in coconut oil but not in palm oil. One of them is aflatoxin, which is carcinogen, and all need to be avoided. Another is 2 and 3 MCPD, which is high in palm oil and low in coconut oil, and also glycidyl esters that are more found in palm oil and less found in coconut oil. All these substances have negative health effects that are expected, and therefore they need to be avoided. In Malaysia and Indonesia, they developed technology for palm oil processing to prevent formation of 2 and 3 MCPD and GE during refinery and or remove them when present. They also advise no chlorine containing fertilizers and to be aware that no bruising of fruits happens in transport, as that will facilitate the formation of those substances. Traded palm oil need to comply to new international standards on maximum 2 and 3 MCPD levels. Therefore, there is no risk at import of palm oil. And finally, the socio-economics. In Indonesia and Malaysia, oil palm replaced rubber and annual crops because it was more profitable per hectare and because labor requirements were lower. Oil palm is typically suitable as smallholder crop, as revenue from a few hectares is sufficient for an income equal to minimum wage. Palm oil is the cheapest vegetable oil for cooking oil for consumers and for feedstock for biodiesel. Economies from Indonesia and Malaysia largely benefit from palm oil for export revenues and local employment in production, processing and services related to the palm oil chain, all contributing to GDP. So in conclusion, oil palm is more productive than coconut in terms of tons of oil per hectare. Oil palm uses land, water and nutrients efficiently and more efficiently than coconut, rubber and tea in terms of usable output per hectare, per kilogram of nutrients and per liter of water. In oil palm plantations, like any other crop, soil erosion and water runoff, both associated with carbon and nutrient losses, are prevented when soil is covered by vegetation, by crop residues, compost and or manure. And in all plantation crops, biodiversity is lower than in primary forest. But biodiversity in oil palm can be facilitated by soil cover, low use of pesticides and herbicides, and site-specific weeding, alley cropping, and grazing. Further conclusions are that in oil palm, technology is available to treat wastewater, to capture methane for bioenergy and reuse nutrients as fertilizer, for instance. Palm oil is healthy and safe, but may contain 2,3 MCPD and GE, which need to be removed during processing to comply to international standards. Technology to do so is available. The palm oil sector is important for economic development of companies, smallholders, and nations such as Indonesia and Malaysia. From Indonesia and Malaysia, we learned that for a successful sustainable palm oil sector, support and investment from private sector, supportive policies and control by national government, and dedicated national palm oil research institutes are needed. So sustainable palm oil is possible for all. And for more details, read the report Myths and Truths of Oil Palm that has been published by Solidaridad Network in 2021. I thank you very much for your attention.